Find the equivalent resistance between the terminals A and B. So this is terminal A, this is terminal B. We have to determine the equivalent resistance between A and B. So in order to make this circuit more easy to solve, and if you observe carefully, we have here in this circuit there are only resistors are there. So I have assumed some notations for each and every resistor. Okay, I have assumed some notations. I have given notations to all the resistors. So this is it from R1, R2, R3, R4, R5, R6, R7, R8 and R9. Total 9 resistors are there. I have given notations to each and every resistor. Now if we carefully observe these 3 resistors, R2, R3 and R4, R2, R3, R4, they are connected in series. R2, R3, R4 are connected in series. So since these 3 resistors are connected in series, simply to determine the equivalent resistance of these 3 elements, simply add the resistance values. 4 plus 4 plus 4, you will get 12 ohms. Equivalent resistance of these 3 elements. I have given some notation to this, that is R10. R10 is equal to what? 12 ohms. R10 is 12 ohms. R10 is 12 ohms. Now we can replace all these 3 elements, all these 3 resistors by a single resistor whose notation is R10, whose value is 12 ohms. So this is my modified circuit. You can say this is R10 whose resistance is 12 ohms. Now if you observe here R8, R9 and R6. R8, R9 and R6, these 3 resistors are also connected in series. So therefore the equivalent resistance of these 3 resistance values equivalent is 2 plus 2 plus 2. Since they are connected in series, simply add the resistance values, that is 2 plus 2 plus 2, you will get 6 ohms. And this 6 ohms, I have given some notation to this 6 ohms, that is R11. So all these 3 resistors are replaced by some single resistor whose notation is R11 and whose value is 6 ohms. So redraw the circuit, modified circuit. So if you redraw the modified circuit, you can see this. So R11 whose value is 6 ohms. Okay, so now if you carefully observe this circuit, modified circuit, we can see that the starting end of 12 ohms, 4 ohms and 6 ohms, the starting end of these 3 resistors is connected at a junction, and finishing end of 12 ohms, 4 ohms and 6 ohms is connected to a junction. So we know when elements are connected in parallel, their starting end they will have a common starting end and they will have a common finishing end. Okay, so starting point and finishing point of these 3 resistors, okay, front end and back end of these 3 resistors is front ends are connected to a common point and back ends are connected to a common point. So we can say this 12 ohms, 4 ohms and 6 ohms are connected in parallel. So R10, R7 and R11 are connected in parallel. Okay, so the equivalent resistance is 12 into 4 into 6 divided by 12 plus 4 plus 6. So you just solve it, you will get 13.09 ohms. So I have given some notation to it, that is R12. So R12 is equal to 13.09 ohms. Okay, so I have simplified this whole parallel circuit. All these 3 elements are connected in parallel. Therefore I have simplified these 3 elements Okay, and I have got 13.09 ohms as the equivalent resistance, and whose notation is R12. So now modify the given circuit and redraw it. This is my modified circuit. This is my R12 whose value is 13.09 ohms. R1 is 5 ohms and R5 is 6 ohms. Okay. Now these three elements, if you carefully observe, they are connected in, these three elements are connected in series. Okay. They are connected in R1, R12 and R5. They are connected in series. Therefore, R equivalent resistance is 5 plus 13.09. Equivalent resistance R equivalent is 5 plus 13.09 plus 6. If you add those three, you will get 24.09. So you can further modify the given circuit, replace all the resistances by a single resistance value whose value is 24.09. That is our resistance between terminals A and B. Okay, equivalent resistance between terminals A and B. So next problem, write the node voltage equations, determine the currents in each branch for the network shown in the figure. Determine the currents in each branch for the network shown in the figure. So if it is mentioned node voltage equations, that means that we have to implement Kirchhoff's current law or nodal analysis. We have to go for nodal analysis to determine the current in each branch. So you can see here there is a 10 ohms resistor, 3 ohms resistor, 5 ohms resistor and 1 ohm resistor. We have to determine the current in each and every branch here. Okay, so now let us solve it. So first of all, what I am going to do is I am going to assume the node voltages. Okay, for that let us see how many nodes are there in the given circuit. This is one node, this is one node, this is one node and this is one node. Okay, total 4 nodes are there. But if we observe this node and this node, there is no element between these two nodes. So potential between these two nodes will be same. Since the potential between these two nodes is same, the potential difference between these two nodes is 0. Potential difference between these two nodes is 0. So instead of assuming two nodes, I have assumed a single node. I have given some node notation for that node, that is 3. So that is our reference node whose voltage is always 0. So this is our reference node. Reference node voltage is 0 volts. And this is one node, I have assumed it as node 1. This is another node, I have assumed it as node 2. Voltage at node 1 is, node voltage is V1. Voltage at node 2, that is node voltage is V2. So our node voltages are V1 and V2. Okay, another node is also there, that is our reference node whose value is always 0. Okay. Now let us assume the current directions at node 1 and node 2. So our wish, we can assume any direction, either we can assume all currents are leaving the node, we can assume all currents are entering the node, we can assume some currents are entering and some currents are leaving. So here if you see at node 1, okay, at node 1, this is node 1, this is node 2. At node 1 I have assumed one current entering, other two currents are leaving, whereas at node 2 I have assumed all the currents are leaving the node. Okay, at node 1 only one current is entering, at node 2 all the currents are leaving. So now let us apply Kirchhoff's current law. Okay, let us apply Kirchhoff's current law at node 1, whose node voltage is V1. So at node 1, what is the algebraic sum of entering currents at node 1? Only one current is entering, that is 5 amperes. So entering current is equal to algebraic sum of leaving currents. How many currents are leaving node 1? 2 currents are leaving node 1. Okay, so one current is flowing from V1 to the reference node, Okay, so V1 minus 0 divided by 10 plus, so minus 0 we need not write, it's not important. So minus 0 is not important because even if you subtract or add with 0, it won't make much difference here. So therefore we are not writing minus 0 here. I have written V1. This is V1 minus 0 by how much resistance? Voltage by resistance is nothing but current. So that is 10 ohms. Next. Now at node 1 another branch is there. This is one branch. Okay, this is another branch. So that branch is 3 ohms resistance is there in that branch. So what is the current flowing in this 3 ohms? That is V1 minus V2. Current flows from V1 to V2. Therefore V1 minus V2 by 3. Okay, voltage by resistance is nothing but current. Now simplify it. Okay, you will get 5 equal to V1 by 10 plus V1 by 3 minus V2 by 3. 5 equal to V1 into 10 by 1 by 10 plus 1 by 3 minus V2 into 1 by 3. So consider it as equation number 1. Now let us write the nodal equation at node 2, where node voltage is V2. Node voltage at node 2 is V2. Okay. So here at node 2 I have assumed all the currents are leaving. So how many currents are entering here? Since all the currents are leaving, algebraic sum of all the currents entering is 0. Nothing is entering, all are leaving this node. Okay, all the arrow marks are, you can see they are away from this node. Okay, so now what is the current in this 3 branches? 3 branches are there at this node. So what is the current in this branch? V2 minus V1 by 3. Okay, next V2 minus 0 by 5. Next V2 minus 10 by 1. V2 minus 10 by 1. What is 10? This is our source voltage. Okay, V2 minus 10 by 1. Just simplify it. 0 equal to V2 by 3 minus V1 by 3 plus V2 by 5 plus V2 minus 10 you will get if you simplify this whole expression. Okay, now let us further simplify it. So if you further simplify, you will get 10 equal to minus V1 of 1 by 3 plus V2 of 1 by 3 plus 1 by 5 plus 1. So consider it as equation number 2. Now solve equation 1 and 2. You will get V1 as 19.85 volts and V2 as 10.9 volts. Now what is the current in 10 ohms resistor? Current in 10 ohms resistor. This is our 10 ohms resistor. What is the current? That is V1 by 10. V1 by 10 is the 10 ohms resistor current. So V1 by 10, substitute V1 value here 19.85 by 10. You will get 1.985. Similarly, current in 3 ohms resistor. That is V1 minus V2 by 3. V1 is 1.985 minus V2 is 10.9. All divided by 3. If you simplify it, you will get 2.98. Similarly, current in 5 ohms resistor is V2 by 5. That is 10.9 by 5 equal to 2.18 amperes. Similarly, current in 1 ohm resistor is V2 minus 10 by 1. That is 10.9 minus 10 by 1 equal to 0.98 amperes. So these are all the branch currents. All these are the branch currents in the given circuit, which we have obtained by applying nodal analysis or Kirchhoff's current law. So next problem. In this problem, in the circuit shown below, determine all the branch currents using mesh analysis. So here in this circuit we have to determine the branch currents, means current in 4 ohms, current in 8 ohms and current in 6 ohms. Okay, by using what? Mesh analysis. Mesh analysis means you have to implement Kirchhoff's voltage law, KVL, Kirchhoff's voltage law. So first of all, let us check how many meshes are there. Let us see how many meshes are there here. How many meshes are there? This is one mesh. This is another mesh. Okay, how many meshes are there? Mesh 1, and mesh 2. Okay, two meshes are there, so we can assume two mesh currents I1 and I2 in any direction that we want. Here I have assumed clockwise direction. The current direction I have assumed clockwise in this mesh 1. In mesh 2 also I have assumed clockwise. Okay, so this is my I1 current, this is my I2 current. Okay, I1 current and I2 current, mesh 1 and mesh 2. Okay, so now let us apply Kirchhoff's voltage law to determine the I1 and I2 values. Now apply KVL in mesh 1. So I'm keeping my circuit here so that it will be easy for me to explain. This is it. I will expand this screen. So this is it. Now if you see, this is our mesh 1. So according to Kirchhoff's voltage law, algebraic sum of all the voltages in a closed path must be equal to 0, or algebraic sum of the source voltages must be equal to algebraic sum of the voltage drops in the closed path. So if you see in this mesh 1, there are three elements. One is the source and two resistor, 8 ohms and 4 ohms resistor. Okay, total 3 elements are there. So algebraic sum of source voltage is equal to voltage drops, algebraic sum of the voltage drops. So let us see, I am going to use that statement here. So 42, algebraic sum of source voltage is 42, equal to, what is the voltage in 8 ohms? 8 into resistance into current, 8 into I1. This is the voltage in 8 ohms. What is the voltage in 4 ohms? If you observe, 4 ohms is in between two loops or two meshes, in between mesh 1 and mesh 2. So if you observe the current direction in mesh 1, it is downward. If you observe current direction in mesh 2, it is upward. Both are opposite to each other. Okay, both are opposite to each other. Therefore, differential current will flow through 8 ohms, that is 4 into I1 minus I2. 4 into I1 minus I2. Now simplify this, you will get 42 minus 8 I1 minus 4 I1 minus I2 equal to 0. And further if you simplify, you will get 42 minus 12 I1 plus 4 I2 equal to 0. And further if you simplify, you will get 4 I2 equal to 12 I1 minus 42. And at last you can rearrange the terms, you will get 12 I1 minus 4 I2 equal to 42. Consider it as equation number 1. Okay, consider it as equation number 1. Now let us go to equation mesh 2. Let us go to mesh 2. So in mesh 2, if you see, there is one voltage source and two resistors are there, 6 ohms and 4 ohms. So voltage source value is 10 volts. Algebraic sum of voltage sources in this loop is only 1, that is 10 volts, is equal to, what is the voltage in 6 ohms? 6 into I2. What is the voltage in 4 ohms? This 4 ohms. It is you can see it is in between two meshes. Therefore you just see the direction of current besides to this resistor. This is downward, this is upward. So I2, since we are in mesh 2, therefore I2 minus I1, differential current will flow through 4 ohms, that is I2 minus I1. Just simplify it, you will get minus 4 I1 plus 10 I2 is equal to 10. Consider it as equation 2. Now simplify equation 1 and 2 to determine I1 and I2. So if you simplify 1 and 2, you will get I2 as 2.76. Sorry, this is I1 Yeah. This is I1, not I2. I1 as okay, substitute I2 value in any equation 1 or 2. I have substituted in equation 2 and I have got I1 as 4.42. Okay, I1 is 4.42 amperes, I2 is 2.76 amperes. Now we have got the loop currents or mesh currents, we can say. So we have got the mesh currents. Let us determine the branch. What did they ask? They have asked us to determine the branch currents. So what is the current in 8 ohms resistor? It is I1 current flows through 8 ohms resistor. So I1 current we already know, that is 4.42 amperes. Okay, so current in 8 ohms resistor is how much? 4.42 amperes. Now in 6 ohms resistor I2 current flows. You can see the circuit. In the circuit it is mentioned. You just, if you see the circuit, you will come to know how much current flows through the 6 ohms. That is I2 current. Just now we have calculated I2 current. How much is it? 2.76 amperes. Now in 4 ohms resistor differential current flows. Okay, differential current flows. So it is the difference of I1 and I2. Difference of I1 and I2 is 4.42 minus 2.76, that is 1.66 amperes. Okay. So these are the branch currents. In 8 ohms resistor I1 current flows. In 6 ohms resistor I2 current flows. In 4 ohms resistor differential current flows. So in 8 ohms resistance value, in 8 ohms resistor current is 4.42. In 6 ohms resistor current is 2.76. In 4 ohms resistor current is 1.66 amperes.